Okay, just a reminder that we've seen things like this before, and what I want to remind you is that we know what e to the x is. We've done this when we did Taylor series. That's going to be 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x4 over 4 factorial, yada, yada, yada. E to the minus x, well, it's going to be 1 minus x plus x squared over 2 factorial minus x cubed over 3 factorial minus plus x4 over 4 factorial. You get the idea, all right? So I want to write down e to the minus 1. E to the minus 1. What do you get there? Well, we just did it, right? So we get 1 minus 1 plus 1 over 2 factorial. Let's see, minus 1 over 3 factorial plus 1 over 4 factorial. Let's see, minus yada, yada, yada. All right? So I'm going to say 1 over e is equal to, let's see, 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial minus 1 over 5 factorial. You get the idea. Get my eraser out. Erase this business over here, old business. But I should recognize old business. And I have to go back and review my notes to do that, but I should recognize it. So what I want to do is write this one down so it sort of looks like that. And I'd factor a 3 out. And you get the sum, n equals 1 to infinity. This would be minus 1 over n plus 1 over n factorial. This is 3. And if I put 1 down there, you'd get 1 over 1, which is 1. Then I get minus 1 over 2 factorial. Then I get plus 1 over 3 factorial, minus 1 over 4 factorial, and so forth and so on. All right? It looks remarkable. What I mean by that, it looks sort of like what I have down here. It's not the same, though. So what I want to do is multiply, the 1 over e by minus 1. What do you get? Minus 1 over e. And what does that equal? Well, it would equal minus 1 over 2 factorial. I see that there. Plus 1 over 3 factorial. Minus 1 over 4 factorial. Again, I'm seeing these things over here. Then plus 1 over 5 factorial. And it looks pretty obvious that there's some similarities between the two. But I don't have count for this one, so I'll put that down. I'll write down add 1 to both sides. I got this. And I got this part, but I don't have the 3 yet. So let's put that in there. What do you get? 3. Put a 3 over here. And we have it. What's this sum going to be equal to? 3 minus 3 over e. I'm going to get my eraser out. They didn't ask me to do this, but I want to point out it might be a good idea to understand it can be done. I found that sum. What they're asking me for, though, is they're asking for what value of n. So they want to approximate this thing. So what value of n, when I say n, big N, uppercase N, and that's 3 minus 1, n plus 1, n factorial. All right, what n do I need to make this accurate to within 4 decimal places? So we're hoping that you're reading the textbook, and they talk about this. And I do understand a lot of students don't read textbooks. They just what they get in the classroom. That's only a minor part of your education. Part of your education is going to be reading your textbook, right? And possibly reading other textbooks as well, by the way. Some textbooks you might find more easy to read than others, all right? More informative to you. It's typical for undergraduate students to have multiple textbooks for given courses, by the way, particularly a course like calculus. All right, so what I'm going to do over here is, if you're reading a textbook, you're certainly seeing something like this in your textbook, right? It's about approximating these things, right? What are they saying? They're saying that, the nth approximation of this is the Sn, by the way. Whoops. All right? This is the Sn. And this over here is just the S. It's the actual sum, right? They say the difference, the absolute value of the difference between those two is going to be less than or equal to. So here's what they're claiming over here, that for some n, whatever it is, minus s, the absolute value of that, the difference, is going to be the nth plus 1 term. What's that going to be? Well, let's write this down. AN is going to be 3 over n factorial. So the nth plus 1 term is just 3 over n. I'm sorry, I should use the big N. Big N plus 1, uppercase N, factorial. And we want it accurate to 4 places. So I'm going to be looking, I want to go past the 4th place, go to the 5th place. So I want to make sure that this guy over here, to do that, is going to be 1 over 10 to the 5th. That'll bring it to 5 places, by the way, which is 10 to the minus 5. Right, same thing. All right. So what I'm going to do over here, let's write this down and put this down. And we want 3 over the big N plus 1 factorial. And we want this thing to be like this. And that's going to be, oh, I'm sorry, not that way. I want it to be smaller than. I don't want the area to be larger. I want it to be smaller than this. 1 over 10 to the 5. Got to solve that. And I know it's difficult. I would say that if you read this question over here, I wouldn't put this question on an exam, by the way. But you should be able to do something like this, particularly if it's a homework question. It might need a calculator, by the way. So what do you get over here? Well, to multiply it out, you can get 3 times 10 to the 5th power, and then n plus 1 factorial. Now, granted, it does take some playing with this. I mean, you could say, oh, I think n is 0. Unlikely, but it's actually not likely. If you took n to be 1, what do you get? Well, 2 factorial. That's certainly not true. Then you might say, oh, what happens if I take n to be, let's put 4 down. You say I'm jumping, I'm missing things. That would give you 5 factorial. What's 5 factorial going to be? Let's see, 5 times 4 is 20. Let's write that down. 5 times 4 times 3 times 2 times 1, 20, 60, 120. That's not bigger than that. So I got to kind of go through them. I will say this, though. You'll arrive at the number for the n equals 8. In other words, 9 factorial, that's when n equals 8. This would definitely make this thing greater than 3 times 10 to the 5th, all right? Again, you can use a calculator if you want to. I hope you're somewhat of a doubting Thomas, and you're saying, gee, I wonder if that's true. And what I did was I did use a computer algebra system. I can't remember the way I did this in my notes. These notes are pretty old at this point. But I'm going to say Sage is a great option. And I'll probably post a video for that. But anyway, it'll compute a number over here, this over here. And again, we already did this over here. And you look at this number over here, and this thing is accurate. Let's see, 1, 2, 3, 4. 1, 2, 3, 4. It's accurate to 4 places, by the way. All right. Now again, if you I'm sorry, I didn't mean to do that. That's not the one I want. This is the one I was saying accurate, right over here. Sorry about that. So let's take a look at this one over here. Accurate to the 4 places, right? So looking at it, you know, I'm seeing this over here. You see the idea, we're getting accuracy to 4 decimal places. All right, so let me see if I, yeah, I rounded it off. This is rounded off up here, round off. And that's about it. And we did it. Thank you.